Ovi, and I'm sure. All right, so I'm gonna do that again, seeing that we just started recording. Welcome everyone, and thank you for joining us for today's webinar. My name is Akinla Mo, and I'm a competency engineer in the 3D Services Organization at HP. My co-host is Mitch Novi. Mitch is the training lead for the AMS region. He's also the training lab manager within the 3D Services Organization. Today, what are we going to be talking about? We will be talking about the new robust print profile that was released a few months ago. And one of our competency engineers, Thomas Laverick, will be facilitating the session. Tom in his presentation will cover some features of this new print mode. He will compare the new print mode to other existing print modes. He will try and explain how to install this new print profile and also provide information on where to find documents that may help you understand this new print mode better. A little bit of housekeeping before we get started. If you have any questions during the presentation, please type them into the chat box in your Zoom control panel. We'll bring them up during the presentation, and we'll also have some time at the end of the webinar to take questions. Having said all of that, I will now turn over the time to our presenter, Thomas Laverick. He's one of our leading engineers within the services organization, and I'm sure most of you have had reasons to interact with Tom on a number of cases in the past. Over to you, Mr. T.
All right, thank you, Keen. Guys, what we're going to cover today is the basics of the robust print mode, getting it up and running, and where you can go and find the white papers for further questions or answers. And don't hesitate to post your questions at the end or during the session. You can post them into the Q&A section and we can get them answered for you today. All right, so we're going to spend about 15 minutes on the content and then another 15 minutes for questions and answers, unless we need to go over into some of the explanations of the content. So the new PA12 print profile is only compatible with the 5200. It's not backwards compatible with the 4200. The 4200 has already a long, lengthy cycle that takes 16 hours for a full bucket to print. And with the balance mode of the PA or the 5200, we've actually reduced that to about 11 hours. And with robust mode, we move up in time to about 13 and a half hours. Robust mode has been available since September 28th of 2022, and it was released in BD7 or version 16.22.20.39. As of that date, advanced print profile has been discontinued and is no longer available in the firmwares, unless you have special provisions through HP to have that advanced print profile over the robust in your machine. Robust improves the repeatability as far as mechanical properties and dimensional accuracy are concerned, and they go. It provides better surface roughness thanks to the multi-speed alignment and a feature built into the firmware that we actually control some of the speed, reduce the speed of the carriages that allow more melt time into our parts. And then we also improve the thermal process uniformity in the X, Y, and Z axes. And we also gained a reduction of bubbles in parts. For those of you who are familiar with fine features that are facing upward, we can get bubbles in those on the balanced mode. Advanced mode was designed to remove that, and robust mode was built off the advanced to give us a better look and feel overall of the part. For the applications, this print mode is beneficial when printing thin parts or parts with high level of detail, where parts require good surface quality and assembly with critical dimensions. Printing time of a full bucket takes approximately 13 hours, 25 minutes for a full build. We increased the layer thickness from 80 microns to 90 microns to help reduce the overall time from the 16 hours that we would have saw. And that also gives us a little bit thicker of a layer height than we did with the balanced and the advanced print modes. Mechanical properties, we gained up to 10% on tensile strength and up to 5% on elongation at break. And the the print profile is still a single pass print profile. And the mix ratio, it goes back to an 80-20. So it's 20% fresh to 80% recycled, as opposed to advanced, which we recommended a 70-30 mix ratio. And tensile strength can be defined as the maximum strength that material can bear before breaking when it is allowed to be stretched or pulled. And tensile strength is usually reported in units of force per unit, such as pounds per square inch or megapascals per square or megapascals. Elongation of break, also known as a fracture strain or tensile elongation at break, is the percentage it would increase in length that the material can achieve before it actually breaks or becomes so elastomeric that it just no longer holds form or cannot return to form. The ASTM testing that is done is for the American Society of Testing and Materials, and these are type 1 specimens as defined by the ASTM. The tensile modellus or Young's modellus is a measure of solid stiffness or resistance to elastic deformation under load, and it relates to stress, force per unit area, or strain proportional to deformation along the axis or a line in the part. A low Young's modellus value means that it's is elastic. A high Young modellus means that the solid is a inelastic or very stiff or rigid part. Elongation at yield is the ratio between increased length and initial length at the yield point. The yield point is defined as the stress beyond which a material deforms by a relatively large amount for a small increase in the stretching force, or the stress beyond the material becomes what we call plastic or malleable at that point. Impact strength is the measure of the ability of a material to resist cracking, fracturing, or plastic deformation under sudden or intense impact or load of shot. So if we look at our numbers for the tensile strength on for PA12, on the average XY, we have a rating of 54. On the average Z, we're at a rating of 52, defined by ATSM D638. Tensile modellus is 2000. Elongation at yield is 10% in XY, 9% in the Z. Elongation at break is 17 on the XY axis and 10 on the Z axis. Impact strength is 4.2, and that holds true with the Z axis as well. And the density, we're seeing a 1.1, which is a gram per cubic centimeter. So these are all based on internal testing using the HP half commercial data sheet job, and results may vary with other jobs and other part sizes or dimensions. And we also follow the HP recommended printer setup and adjustment process with print heads alignment, semi-automatic alignment procedures. And tensile strength is a typical variation of 95% of parts fell within the 45 to 55 megapascals range, while the tensile modellus for value remains within the 1650 to 2200 megapascal range. And using the load IZOD test method, with a notched part at 3.2 millimeters, 3.2 millimeter specimen, according to the ATSM D256 standard, is where we gathered all this information for these, and you can actually see the build bucket of the test parts that were used right there and how they were placed and sampled. One of the advantages of the robust print profile, it increases our CPK, which in the CPK is a process capability index. It measures the extent of variation in the process experiences relative to its specification limit. The higher the CPK value, the better off you are, the more usable parts you're getting per print or per 1,000 parts. since a CPK of 1 indicates that 99.73% of your parts are produced within spec limits. In this process, it is likely that only about 3 out of 1,000 parts need to be scrapped or rejected. A CPK of 1.3 means that 99.994% of the product is within specification. Keep in mind, when you're measuring specification, you have an XR chart, min, max, and a mean level. Once you determine your mean level, then you go your min, max, and all your parts should fall within that min and max. And you'll get some variations that are going to go outside of it. And this is all based off internal testing with the tolerances set forth by the ISO standard that we utilize. If anybody remembers, we have a process control software that you can print a bucket of parts, send them out to have the metrology done, where this can all be fine-tuned toward you can reach the CPK of 1.33 range. Some of the features of the robust print mode over the balanced, advanced, or the 4200 balanced. Print pass on the 4200 is 2 passes per layer. And when we step into the 5200, that was reduced to 1 pass, and it continues through all the print modes within the 5200, including robust. Printing time, a full bucket of parts on a 4200 was 16 hours. At balanced mode on a 5200 series, it was 11 hours, 30 minutes. Advanced mode, it increased the print time to 13 hours, 40 minutes. And when it comes to robust mode, we're at 13 hours, 25 minutes per full bucket. Layer thicknesses are defaulted at 80 for the 4200 and 5200 balanced and advanced. When we stepped into robust, we increased that to 90 millimeters so that we could help to reduce that time and keep it away from that 16-hour mark. Mix ratio, when it comes to the 4200 on PA12, we recommend a mix ratio of 80-20. 5200 for balance is 80-20. When we stepped into the advanced, we ended up increasing to 70-30. With robust mode, we've actually been able to walk that back to the 80-20 mark over that. And for fusing agent, we see that the CB there in the 4200 series for fusing agent and detailing agent, that's crate balanced mode. It's just the amount that is used for crate versus the other, or for the 5200 print mode for balanced. The 4200 used 4 times the amount of agents that the 5200 used on balanced mode. Advanced, we used the exact same amount of agents. But when we stepped into robust mode, we get a 2.4 times the CB and 2.2 times the CB in the DA, meaning we're using a little bit more fusing agent, a little bit more detailing agent around our parts. What we can gain out of that is when we step into the robust mode is our job repeatability, look and feel, mechanical properties, density of the parts, dimensional capabilities, and internal dimensions of our parts. We gain a complete point on a scale of 1 to 5, with 5 being the best in class. We've actually moved those products up to a 4, 4.5 in some areas. That whenever we compare printing time, we actually lose a little bit of time because of the longer ratio, or longer print time. But for our recycle ratios, we are back at the 80-20, and we take an overall productivity hit of 0.5. But we're garnering better parts, better repeatability, parts that are smoother, parts that are more accurate, and the look and feel of the part, it actually increases over the balanced mode. For the print profile installation, after the print is set up, we definitely want to run a 7-layer build. And when we run that, after we do our semi-automatic print head alignment, and this is a new alignment function that applies to all materials and print profiles available. And we still have the legacy mode for those that do not have the scanners to do the semi-automatic print alignment or take advantage of it. I highly recommend, if you don't have it, make a plan to purchase the scanner. It's going to get you well within 20 microns of where the print head alignment needs to be done at. Outside of that, with the manual, run your manual print head alignment and then run diagnostics print head alignments after that to fine tune that alignment. You're comparing a digital eye versus a human eye, and the digital eye is going to be able to see finer variations that we're not going to be able to notice even whenever we're using a loop. And we want to ensure that the lamp power is set to 0, and we're going to launch the build plate temperature calibration. And as you can see there, take a screenshot of this screen so you can figure out how to get into it to run your 7-layer build. And what we're looking for is on the outside brackets and then the big squares. So we have the outside brackets. We got the northwest, northeast, southwest, southeast, or southeast, southwest corners and the 4 blocks. The rest of the parts can be fairly discarded. For right now, we don't need to look at them. Our main concern are those big blocks and then those outer perimeters. The first thing we want to do is review the outer perimeters for elephant skin, and I'm sure everybody here is familiar with that. The elephant skin is a uneven surface or non-flat surface due to layer by layer non-homogeneous cooling. And we choose that layer that does not have that. If you have multiple layers that do not have that, we want to compare them all, and we're going to move to the center blocks. And then when we look at the center blocks, we're looking for thermal bleed to be present on them, or white skinning that'll happen. If we see that white skinning, we're going to discard that layer in its entirety, because we want to have parts that are non-elephant skinned and non-thermal bled. If you have slight elephant skin on all layers, choose the layer with the best inner blocks and then adjust by 1 up or down. If you have elephant skin, you're going to go up 1 temperature, just to increase the temperature a little bit. Everything is based off of every level. This build has a different irradiance adjusted or assigned to it. So if we have level 1 is our best part, we're looking at a positive 4 degrees Celsius. If it's level 2's best, that's a positive 3. Level 3 is a positive 2. Level 4 is a positive 1. And level 5 is a 0. That's the default value that we want to set if level 5 is our choice. And level 6 is going to be -1, and level 7 is going to be -2. So whenever you choose the layer that looks the best, you're going to compare that to this, and then you're going to enter those values into which layer you chose on the next portion down of this thing right here. And if it's at 0, we can just ignore it and press 0 and it applies to it. But whenever we choose, we're basing off of this scale up here. So if we have the, in this one, if we selected the first level without elephant skin when moving down the levels, if no elephant skin is found on any of the parts, we want to go default to straight to level 6, which is going to be our -2, or I'm sorry, -1 degree. And then we move on to the next portion of the thing where you can find white papers. If you go to the PrintOS, your PrintOS account login, you go to select the 3D knowledge zone, select the printer of the 5200, and then just in the search bar above, type in robust print profile, and it'll take you there. Or you can go straight to printos.com/knowledge zone. All right, and is there any questions about the robust print profile today? Mitch, I'm going to hand it over to you for the Q&A.
Yes, thank you so much, Tom, for that great information. I think it provided a lot of good clarity points on your new robust print mode. So yeah, like Tom just mentioned, if you guys have any questions, just go ahead. You can either place them in the chat or you can unmute yourself and ask away.
So I see Greg has a question here. Can you enable unmuting ourselves? Unfortunately, no.
Mitch, people are going to have to raise their hand. The participants cannot unmute themselves. So if you put your hand up or post your question, Mitch will unmute you so that you can review that portion.
Mitch, I see a question here from Edward. Do you want to take it? Okay, I see Mitch is muted. I'm just going to ask on behalf of Edward. So Edward is asking, why not just print in this mode all the time? What are the drawbacks? Tom, do you want to take that? Or
Yeah, I'll take it. Edward, the drawback is the amount of time it takes to print a job. Some companies, they are very dependent on their production jobs running 2 to 3 jobs a day. You know, so they run balance mode and they run robust whenever they're running certain types of parts. If your ability allows it, I highly recommend robust mode for all your jobs if it's capable. You know, if you have that kind of time frame.
And then, if I may add to that, Ed, you're looking at choosing the right print mode for whatever outcome you're looking for on your parts. So if you think back to one of the slides where Tom was showing the advantages and disadvantages of the different print profiles, you see that in certain print modes, you get certain advantages, and in other print modes, you do not. So it would depend on what kind of outcome you're looking for. But the robust, as the name suggests, is robust and can cover quite a number of outcomes that are pleasing to the end user. We have a question here from Kevin, and Kevin is saying, can we get the dimensions for the parts in the irradiance tuning view so we can tune it with that as well?
Kevin, I'm not sure if I'd want to use that to tune your for dimensional accuracy. I like to use that 7-layer build as my coarse tuning for irradiance and then fine tune with customer parts. If you're a production facility and you're going to run parts continuously that are similar, I would tune more so to that than I would to a generic build level. I would just use the generic as this gets me in the ballpark and then fine tune to yours. For dimensionals, I definitely would refine based on what you're seeing in your parts. Different geometries are going to have obscured shrink ratios that happen as well, if that makes sense to you.
Okay. And then we have a question from Paul. Paul wants to know if we're going to share this PowerPoint after the meeting, and I can answer that. Yes, we'll share PDF copies of this presentation with every attendee today. Let me see. There's a question from Tyler. Will there be similar profiles and tuning coming to PA11 in the future? Do you want to take that, or do you want me to?
Tyler, at this moment, there is Not plans on having this print profile go to PA 11, but there might actually be something else coming out that is going to allow a lot of this fine tuning for all materials. And it was, we announced the automation process at Rapid, and there's a software side of it that is going to cross-platform between metals and plastics. That's going to allow greater control of the printers in the future.
Thank you, Tom. Mitch, are you back?
Yes, I'm sorry, I had issues with my microphone. I can take over from here.
Okay, so the next question is from Greg.
Yes, let's see here. So can robust print mode help with part quality problems normally associated with aging powder? I'm not sure. How do you feel that there would be a common, it seems as though with a robust print mode that it wouldn't necessarily have an effect on that in a sense of improvement.
Absolutely. I mean, if powder is aging, there's so much quality you can expect from parts built with such with that kind of powder.
It's still going to remain the best practices when you start getting aged powders to increase your mix ratio for a few builds to freshen up what recycled powder is there.
Correct.
Okay. That answers that.
It says here, Paul wants to also share the video recording as well.
Absolutely. Paul, you're going to get everything. You get the PDF format of the presentation. And as soon as we have the videos downloaded, we will send a copy to every one of the attendees.
All right, guys. Do we have any other questions that we want to ask on robust print profile?
I thought I just saw a hand go up.
I think it was someone clapping.
Oh, okay. All right, anyone else have any questions?
I do not think so. So Mitch, if you want to wrap up for us, that would be nice. Okay, I'll just do it. I think Mitch has some issues with his microphone. So on behalf of everybody at HP, I want to thank everyone. We appreciate you being here. The next webinar will be taking place on the 13th of June, 2023, and we'll be talking about mechanical properties of some of our materials, the PA11, the PA12, polypropylene, TPU, and other types of materials that we have. Thank you, Tom, for being a great presenter. Thank you, people, for attending. We appreciate your time. And having said that, thank you, and we will see you next time.
Thanks, everyone.